Hey guys, Travis Gillespie here, and we're gonna look at our number system, our whole real number system. But before we even learn it, before you, that's Travis Gillespie. We're gonna look at the real numbers here. But before you get started, what we really need to do is get an understanding how our number system came to be. So as a kid, you probably learned to count watching a show such as Sesame Street. You learned to count the basic numbers 1, 2, 3, 4, and so on. And basically, these were called the real number, the counting numbers or the natural numbers. So the best way, I'm just going to call these our natural numbers. But basically, you learned to count probably up to 10 using the natural or counting numbers. Let's turn that into yellow. Just changing the box up here. We're going to change that to a yellow and then move on, because as you got older, probably more sophisticated, instead of watching Sesame Street, you decided you're going to watch Barney, and you learned that, hey, there's a few more things that natural numbers don't have, and the big one being zero. You said, hey, there's a number zero, and I'm going to start counting at zero. I'm going to count to 1, 2, 3, and I can count maybe even up to 20 at this point. And when you add the zero to this set of natural numbers, 1, 2, 3, and so on, you get a new name, and you call this the whole numbers, whole number set. So within the whole number set, you still have 1, 2, 3. These are the natural numbers. So within the whole number set, you have the natural number set. But whole numbers, again, includes things such as zero. Change colors again and put a good box around that one. I'm going to put the natural numbers also inside of the whole number set. But again, you get a little bit older and you say, hey, that's not the whole truth. There's more to it than 0 and 20. And in fact, rather than just counting in a positive direction, you decide, well, 0 might be a good place to start, but I'm going to move off in the other direction. But before we do, let's put on our 1, 2, and at least 3, and say that, hey, these numbers continue on. You already know that. But again, as you get older, maybe you grew up in Texas where it's real warm. You traveled up to a cold area where the temperature drops below 0, and you need to get a jacket. And because the temperature drops below 0, maybe it drops below 1 degree or 2 degrees below 0 in these cold areas, and this goes on, so on. But you need to buy a jacket now to keep you warm, and you traveled without any money, so you ended up borrowing money from somebody else. You have no money on you, so you're borrowing money from somebody else, and now instead of having no money, you have less than no money because you've taken out a loan or borrowed, and you owe somebody money. So this is where negative numbers come into play, and oops, I'm gonna create a box around that. Our negative numbers, when added to the whole number set, remember whole numbers are numbers such as 0 and then all the positive numbers 1, 2, 3, 4, and so on. The negative numbers, when added to these, they give us a set we call integers. These are your integers. So when dealing with more than just 0, 1, 2, 3, and 4, you end up with your integers. But that's not the whole case still. There's still more to the puzzle here, because as you get older, maybe you've paid off your loan for a jacket, but you start going out on dates or hanging out with friends, and at this point, you start to buy cool items or good stuff such as pizza. And the pizza, everybody wants a piece of pizza, and You're not going to eat a whole pizza if you're with a group. You're just going to have a piece or a part of that pizza. So to describe that, you start telling people that you only want a part of it. And if there's 6 pieces to a pizza, you're only going to eat one piece. So you start using integers um, to describe how much you ate. Instead of eating a whole pizza, you only ate a part of it. Maybe you ate 1 out of 6 pieces. So you're taking integers and plugging in them to the numerator and denominator. So really what you're doing here is you are writing numbers as fractions. And again, fractions are where we have integers plugged into the numerator and denominator, where the numerator is on top, denominator is on bottom. So fractions, when we have fractions written up, when we have integers in our numerator and denominator, or so whenever you have anything written in the form of a fraction, then you actually do have what we call something. So whenever anything's written in the form of a fraction, it's called a rational number. And let's just say I have 1, 2, 3, and again, so on. So we call these our rational numbers. And let's look at this a little bit more, because somebody could say, well, wait a second, 2 is a whole number. But 2 can be written as, do a little arrow here, 2 can be written as a fraction when you say 2 over 1. So now you have your natural numbers, your whole numbers, your integers, and rational numbers. We're going to box this one up. Now let's just review this for a second. You first started out with natural numbers, the counting numbers, 1, 2, 3. And then you moved on, you added 0, and 0 included the natural number, no, and you added 0, and this created the whole number set. And then the whole number set included natural numbers such as 1, 2, 3, and 4. And then you grew up a little bit more and you realized, well, there's these things called negative numbers. So when you add integers, when you add negative numbers to the whole number set, you end up with something called integers. And from there, you realize, well, wait, I can take integers and create fractions from them. And whenever anything's written in the form of an integer, whenever anything is written in the form of fractions using integers, you have what are called rational numbers. And a rational number is it's a ratio of integers. And a fraction is a ratio of integers. Now disconnected from rational numbers, I'm going to move the screen over some, maybe bring rational back in, but disconnected from them, you have a set of numbers that are called you have a different set of numbers. That's kind of tough to see. Let's find a color that is disconnected from them. You have a set of numbers that are different than rational numbers. And what we call them are irrational. Irrational numbers are numbers now disconnected from our rational numbers, numbers that are different. They're disconnected from rational numbers. There's a set is a group called your irrational set, irrational numbers. And these are numbers that include pi, or the square root of 2, the square root of 10, or the letter e, pi, e, square root of 2, square root of 10. And the reason is they cannot be written as a fraction. These numbers cannot be written as a fraction because they have non-terminating or non-repeating decimals. Now when you add irrational numbers together with rational numbers, you get a new set of numbers. You get a new set of numbers. Now when you add the set of irrational numbers, when you add the set of irrational numbers to the set of rational numbers, you get a new set, and this new set is called will be called and this new set is called the real numbers. And the real numbers include both the rational and the irrational numbers. Now, when you get to progress, now when you progress further in math, blah 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 blah,